So here are some directions on how to solve this differential equation with the integration factor. So you can pause the video and write these directions down. So the first step that we want to do is write the differential equation as this form: y prime plus p of x y equals q of x. So as long as it's in that form, make sure that you are ready to proceed to step 2. If not, you might have to divide a couple of terms out to make it into that form. The next thing that we want to do is find the integration factor. So like I said in the previous video, this is basically the formula that you're going to be doing. So e to the integral of p of x dx. We are going to omit the constant, okay? The third step, multiply the differential equation by this integration factor, I of x. Then you want to express the left-hand side as d over dx of the integration factor times y. And so basically that's just the reverse product rule. Integrate both sides and then solve for y. Okay, and if there is an initial condition, so if you have an initial value problem in IVP, then you want to solve for the value of c. Okay, so let's start doing a whole bunch of examples so that we can start getting really familiar with integration factor, differential equations with integration factor. So solve the first order differential equation. Okay, so let's start off with y prime plus 5 over x y equals 24x squared. Okay, so the first thing that we want to know is this in the correct form? And actually it is. We already have it in this form. Okay, because y prime is by itself, you have a p of x and you have a q of x on the other side. So the next thing that I want to be able to do is find the integration factor. So my integration factor, I of x, is going to be equal to the e to the integral of p of x dx. In this case, the p of x is equal to 5 over x. So it's just this guy. I'm going to take the integral of that. That's going to give me 5 ln of x plus c, but we're going to omit that. We're going to put the 5 on the top. So we have e to the ln of x to the power of 5, which is in turn going to give me x to the power of 5. Okay, so my integration factor is going to be x to the 5th power. So that's exactly what I'm going to do. I'm going to multiply this x to the 5th to every single term. So this y prime is going to get an x to the 5th. X to the 5th is going to be multiplied by 5 over x, y. And then x to the 5th going to be multiplied by this 24x squared. So everything in parentheses is basically what I had before, and I'm multiplying x to the 5th to every single term. Okay, now what I'm going to do is I'm going to simplify this. So I have x to the 5th y prime plus 5x to the 4th y is equal to 24x to the 7th power. Okay, now that I multiplied by x to the 5th, the integration factor, now what I'm going to do is I'm going to reduce this to a reverse product rule. So this is just going to be d over dx of the integration factor, which was x to the 5th, and the y value. And you can see that if I take the product rule of this guy, I just get the top part. Is equal to, nothing happens to the right-hand side. And now let's just take the integral to both sides. So I'm going to be left with x to the 5th y is equal to 24x to the 8th divided by 8 plus c. So I have x to the 5th y is equal to 3x to the 8th plus c. And then finally what you want to be able to do is just divide by this x to the 5th to all the terms. So what I'm left with is y is equal to 3x to the 3rd power plus c over x to the 5th power. So this is my solution. You can also write it as 3x to the 3rd power plus c x to the negative 5. This is still correct as well. Okay. Notice that this problem did not have an initial condition, so we're going to leave the c by itself. If I had an initial condition, then I would be able to solve that. Okay. All right, so now let's do another problem. Part B. So let's say we have x plus 1, y prime plus y is equal to 2x. Okay. So the first thing to note is that this is not in the form that I want it to, because if I look at how it's supposed to be, you're supposed to have, whoops, I went too far. You're supposed to have a y prime in the very beginning. So in this case, you have a x plus 1 in the beginning. So we have to move it over. Okay, so divide by x plus 1, divide by x plus 1, divide by x plus 1. Okay, so this is going to go away. I'm left with y prime plus y over x plus 1 is equal to 2x over x plus 1. Okay. So now what you want to do is you want to find the integration factor, now that we have it in this form. So the integration factor, I of x, is going to be equal to e to the integral of p of x. P of x is equal to 1 over x plus 1 dx. So this is just going to give me e to the power of natural log of x plus 1. So then the ln and the e go away, so I'm left with x plus 1. So this number is what we're going to go ahead and multiply. Okay, now you're going to see what happens. So something weird happens. So I'm going to multiply every term by x plus 1. So this y prime is going to get an x plus 1. This other part is also going to get an x plus 1. And then this other part is also going to get an x plus 1. Okay, so now this is going to go away. This is going to go away. So I'm left with x plus 1 y prime plus y equals 2x. This looks very familiar. This was just the original problem. Okay, so did we just go in a full circle? Well, we kind of did. But note that this is not always going to happen. In this case, it did happen. It was already in the form that we kind of wanted it. We just did an extra step, but it's not always going to be like this. Okay, so just be very careful. So now all we got to do is just take the derivative of this, or reverse product rule of the integration factor, which in this case was x plus 1, and the y value. Okay, now we're going to take an integral to both sides. So I'm going to have x plus 1 y equals, this is just going to give me x squared plus c. And then all we have to do is just add x plus 1 to both sides. So I'm left with y is equal to x squared plus c over x plus 1. Okay. Again, I didn't have an initial condition, so I don't have to do solve for the value of c. Whoops. Okay. So now let's do part c. So let's say we have y prime plus cosine of x, y equals cosine of x. All right, so it's already in the form that I want it to. So now what I'm going to do is I'm going to take the integration factor. So integration factor is going to be e to the integral of p of x dx. So p of x in this case is equal to cosine of x dx. Take the integral of this, it's going to be e to the sine of x. Okay, notice that in this case, nothing canceled out. So this itself is my integration factor. Okay, so I'm going to multiply every single term by e to the sine x. It's going to be e to the sine x, then y prime, plus e to the sine x, and then I have all of this stuff, cosine x, y, and then e to the sine x, cosine x. So every single term of these guys ended up getting a e to the sine x. All right, now I'm going to take the reverse product rule. So I'm going to write the integration factor, which is e to the sine x, and then y. And you can tell that if I take the product rule of this, I'm going to get this whole thing back. The right-hand side stays by itself. And now all I want to do is just take the integral to both sides. So integrate and then integrate. So I'm left with e to the sine x times y equals, so this guy right here, we're just left with the integral of e to the sine x cosine of x dx. Okay, so this guy is just going to be a u substitution. So I'm going to let u equal sine of x, du equal cosine of x dx. So what I'm going to have is e to the sine x times y equals the integral from e to the u. This whole thing is just going to be du. So I have e to the sine x times y equals e to the u plus c. So then let me just plug in the u back. So it's going to be e to the sine x plus c. Okay. So now all I have to do is just divide or solve for y. So I'm going to divide by this e to the sine x to all three sides. Okay. So this goes away. Y is equal to, this thing is 1 plus c over e to the sine x. So something that you can do actually is you can make this a little nicer. Bring this to the top so it will be e to the negative sine x. Okay, that'll make it a little more nicer. Okay. Okay, so notice that when you do the integral, when we have like the reverse product rule, you might have to do a u substitution. It might not be something really nice, so you can have something like you have to use integration by parts or something. So just be aware of that. So let's do one more problem, something that's an IVP. So solve the DE with the given initial condition. Okay, so let's say we had y prime plus 3y equals 12 e to the x, and we have the initial condition y of 0 equals 5. Okay. So now the first thing that we want to be able to do is let's find the integration factor, because it's already in the form that we want it as. So integration factor I of x is going to be e to the integral of p of x dx. So p of x is just going to be this 3. So we're just going to have e to the 3x. This is going to be my integration factor. So I'm going to multiply by e to the 3x to every single term. E to the 3x is going to get the y prime is going to get an e to the 3x. You're going to have e to the 3x and then a 3y, and then e to the 3x, and then a 12 e to the x. So this whole thing is just going to be the reverse of the product rule, which is just e to the 3x times y. And then this thing is just going to be 12 e to the 4x, because this and this is going to give me e to the 4x. Okay, so now what we want to do is take the integral to both sides. So I'm going to have e to the 3x y is equal to 12 over 4 e to the 4x plus c. So cleaning this up, you get 3 e to the 4x plus c. And then finally, we just want to solve for y. So we're going to divide by e to the 3x. So I'm left with y is equal to 3. This whole thing is just going to be e to the 1x. And this, if I move it to the top, it's going to be c e to the negative 3x. Okay, so this would be the solution if I didn't have an initial condition, but I do. Our initial condition is y of 0 equals 5. So y of 0 is equal to 5, so it's going to be 3e to the 0. So I'm going to plug in 0 to all the x's. Y of 0 is just equal to 5. This is going to be 3 because e to the 0 is 1, plus c, this is just going to be e to the 0 also. Move the 3 over, and I get c equals 2. So now that c is equal to 2, I just can plug it back into the differential, back to my solution. I have y is equal to 3e to the x plus 2e to the negative 3x. Okay, and that is my original solution. Okay, so these problems are pretty straightforward, very mechanical. Again, the only thing that you have to be very careful with is just maybe just the algebra. The algebra isn't bad in this case, but maybe what I would just suggest is that be careful with the integration, because the integration itself can be a little bit weird. So this whole integration part, thinking if you might be using like integration by parts or use substitution, that can be a little tricky.